Hello, Philippe. Hello, Martin. Welcome to the Chocolate Academy. Today I'd like to discuss a few recurring problems with chocolate, such as crystallization. I'd like to understand better what is this temperature curve that we're asked to observe behind our cocoa berry boxes, the different melting temperatures and so on. Can you explain it? Of course, there are several curves of crystallization. What's the point? Is it important? It's used to obtain chocolate that shines, that melts easily, and has a good snap. To understand crystallization curves, you must know that there are two different curves. One pertains to dark chocolate couverture, and the other to milk chocolate, white chocolate, and colored couverture. We'll start with the dark chocolate. We heat them to 45 to 50 degrees, then we drop the temperature to 28 degrees, and then move it back up to 31 degrees. You must respect the proper temperatures throughout this process. It's different for milk chocolate, white chocolate, and any colored chocolate. These are heated to 45 degrees for not too long, because milk powder fears heat, so you drop the temperature to 26 degrees and then bring it back up to 28 degrees. If you respect all these steps, you'll have a nice liquid couverture. Okay, you've explained that the factors of time, motion, and temperature are very important in crystallization. But what about polymorphism? It's a word we hear from time to time when we talk about cocoa butter crystals. Polymorphism is actually cocoa butter. There are 6 different kinds of crystal layers, 6 different kinds of crystals. There are very powerful crystals called beta crystals. We direct these beta crystals by using the temperature curve of crystallization during tempering. That's to say that when you're at 45 degrees and drop to 35 degrees, you will generate beta crystals. It's like starting a car. We direct the beta crystals to form. When we go down to 28 degrees, we'll generate a little more than average. And then we go back up to 31 degrees to break the momentum. At that point, we'll see a slight thickening. We see a transfer of texture when we're trying to temper the chocolate. And when we turn to 31 degrees, we have just the right amount of beta crystals. The other crystals are guided. They'll become beta crystals. That's polymorphism. It's actually a strain of crystal that is not originally composed of crystals as such, but during the beta phase of crystallization, we orient them, and they become beta crystals in the short and medium term at the time of cooling. So to summarize, polymorphism is the ability of cocoa butter crystals to become beta crystals. You are talking about a total mass of cocoa butter of 0.6% and thus 40% cocoa butter for a traditional dark chocolate couverture. So in fact, what you need to know is that at 31 degrees, for a total quantity of 40% cocoa in your recipe, there's only 0.4 to 0.6% of the cocoa butter which is in crystalline form in the beta structure. Now, during the cooling period, which can range from 12 to 14 months, the crystals hardening over time, there's 0.4 to 0.6 cocoa butter at the very beginning, and at the end of an hour, there will be 10 to 12%, and it will continue to increase over time. If it's been well directed to form beta crystals, we'll have a perfect structure and the chocolate will have a good snap and easily melt. Occasionally, a product won't pop out of the mold. It seems to be at the right temperature, And yet it is very thick. And yet, it is a very thick couverture, impossible to mold. Do you think problems like this come from overcrystallization? In fact, there are two phenomena. First, it's important to have a couverture that's well-tempered and very fluid at 31 degrees. If that's the case, you'll be able to work the couverture for example, around half an hour without physical changes taking place inside the couverture. But if it starts too soon, you get premature thickening, which is overcrystallization. Overcrystallization is a naturally thickening phenomena of chocolate. It happens when you've lowered the temperature too much, to less than 28 degrees, nearly 26 degrees, and you've generated too many fat solids and too many disruptive crystals. So you raise the temperature, and when you stop at 31 degrees, you will always see that the couverture is too thick. So you'll overheat it a bit to break up the process, but you know that you must go up 1 or 2 or 3 degrees above where you can work the couverture to 33, 34 degrees, really at the maximum, on account of the overcrystallization. If you put a thick chocolate into a mold, it will have a visible whiteness, but you'll be able to demold it. Or it's white on the inside but shiny on the outside thanks to the polycarbonate mold that promotes glossiness. It's true that these curvatures cannot be sold. Other phenomena can occur. One is called overcrystallization, that's associated with pieces of chocolate that drop into a perfect crystallization. Here's an example. When we cast a mold, we turn it upside down and we level it off. That is to say, we remove the small flakes around the mold. When these pieces fall into the mix, they generate a natural thickening due to the fact that we've added products that are already crystallized, and the beta crystals freeze them. What do you advise to avoid that? Can you warm the surfaces of the small chips with a heat gun? What I advise is to cast the molds fully, empty them well, and then normally, you should not have any excess chocolate on the sides. If you do have this problem, you should take them out of the molding process, put them in a separate bowl, and melt them again the next working day. That means that even if the chocolate has crystallized, I can use it again if I want. As many times as you want, on the sole condition that you don't put any water in the chocolate. Chocolate is a perfect product, a splendid product. Now, subtempering and subcrystallization. Subtempering means that there were not enough crystals formed at the moment of crystallization. Often they've started at 45 degrees, but they've not lowered the temperature enough, meaning that they've stopped at 31 instead of 28. And there are 3 to 4 degrees there where it forms a lot of beta crystals. And as it was flat, they were removed systematically, and we are in a situation of subtempering. So the chocolate is very liquid. It shines a lot, but there will be pigmentation with white patches. In the best scenario, only a few white traces are found, and the rest will shine. And you'll have a little contraction, and therefore they often won't pop out of the mold. They have no snap, no shine. They'll be earthy. It'll have a hard time contracting, and it won't come out of the mold. Exactly. So if I summarize correctly, overcrystallization, too many beta crystals, a thick couverture, not easy to use. Subcrystallization, a fluid couverture, which I really like, but afterwards a big problem when I want to pop it out of the mold. Exactly. Thank you, Philippe. You're welcome.
Merci, Philippe. Je t'en prie.